What is today's lesson? Let's see. Elements that belong to column 16 in the periodic table are oxygen, sulfur, selenium, tellurium, polonium, and finally livermorium. We know that elements of any specific column are similar in properties. Based on this point, let's try to write today's lesson. Another element, hydrogen, which is first element in the periodic table and lightest element as well. Oxygen with hydrogen forms hydrogen oxide, which is liquid at normal condition. Hydrogen oxide, which is known as water, that is liquid at normal condition. Again, sulfur, that belongs to the same column. Sulfur combining with hydrogen forms hydrogen sulfide, which is gaseous at normal condition. Oxygen and sulfur belong to the same column in the periodic table, but oxygen with hydrogen forms hydrogen oxide, that is liquid, and sulfur with hydrogen forms hydrogen sulfide, that is gaseous at normal condition. But why? This is today's lesson. As oxygen and sulfur belong to the same column, hydrogen oxide and hydrogen sulfide are supposed to be same under normal condition, but one is liquid, another one is gaseous. Why? This is today's lesson. So let's get started. Hydrogen oxide, which is known as water, its structural formula is this. Here, electronegativity of oxygen is 3.5. On the other hand, electronegativity of hydrogen is 2.1. This is a big difference in electronegativity, as electronegativity difference is more than 0.5. So this bond gets polar, that is covalently bonded electrons of hydrogen and oxygen move towards oxygen, and as a result oxygen gets negative in charge, partially negative in charge, and hydrogen gets partially positive in charge. This hydrogen as well gets partially positive in charge. So water molecule gets polar because of the difference in electronegativity between hydrogen and oxygen. Let's write another water molecule. In this molecule, this hydrogen gets partially positive in charge, this oxygen gets partially negative in charge, it gets partially positive in charge. So these molecules are polar molecules. Now between these two molecules, oxygen here is partially negative in charge, here hydrogen is partially positive in charge. So attraction force is created between oxygen of this molecule and hydrogen of another molecule. So this is the attraction force, which is known as electrostatic attraction force. This is also called hydrogen bond. Definition of hydrogen bond is a kind of attraction force between one electronegative atom of one molecule and hydrogen of another molecule. Then the attraction force created is called hydrogen bond. So in hydrogen oxide molecules, hydrogen bond is created. Let's write another water molecule. Here as well, attraction force is created. This force is created because of the difference in electronegativity between hydrogen and oxygen. And because of the formation of hydrogen bond, water molecules get closer to each other. And that is why hydrogen oxide molecules remain as liquid state at normal condition because of the formation of hydrogen bond due to the electronegativity difference between hydrogen and oxygen. Now let's see about hydrogen sulfide. Hydrogen sulfide structure formula is this. Here electronegativity of hydrogen is 2.1, electronegativity of sulfur is 2.5. In this case, electronegativity difference is low, which is less than 0.5. But there is a difference in electronegativity. Because of the slight difference in electronegativity, this bond gets polar, but polarity is negligible here. Bonds get polar when electronegativity difference is more than 0.5. So here polarity is negligible. Another hydrogen sulfide molecule, this molecule as well non-polar molecule because electronegativity difference is negligible. Another hydrogen sulfide molecule, non-polar molecule. So in case of hydrogen sulfide molecules, there is no attraction force among the hydrogen sulfide molecules. That is why hydrogen sulfide molecules remain apart from each other. That is, hydrogen sulfide gaseous in state under normal condition. So the main point is electronegativity difference between hydrogen and oxygen for hydrogen oxide, that means water. Because of this difference, water is liquid under normal condition, but in case of hydrogen sulfide, electronegativity difference is very low, that is less than 0.5. That is why in case of hydrogen sulfide, bonds polarity is negligible, and as a result there is no attraction force among hydrogen sulfide molecules. For this reason, hydrogen sulfide is gaseous under normal condition. Similarly, selenium hydride, tellurium hydride, polonium hydride are gaseous under normal condition. This is all about physical state of hydrogen oxide and hydrogen sulfide. No more today. Thank you very much.